All right, time to review chapter 2 with some logic and reasoning. So let's get into it here. First question, we want to write a true conditional statement. So you get to make up your own. So I'm going to make one up here about your favorite holiday. Let's see. Now, in class, I use Christmas a lot there. You're probably tired of it. So I'm going to switch over to maybe like Thanksgiving. So if it's Thanksgiving, then I will eat turkey. All right. I like turkey. Turkey's good. Okay. So that is my conditional statement. It's true, or we'll assume it's true. All right. So the inverse, remember, makes everything a not. So we're going to take the hypothesis and conclusion and make them opposites. So if it's not Thanksgiving, then I will not eat turkey. All right. Well, that's not necessarily true because I eat turkey sometimes. And so that would have to be a false statement. All right. The converse. Converse is going to flip these two around. It's going to take the hypothesis and the conclusion and reverse them, giving us if I eat turkey, then it is Thanksgiving. Well, so that's the converse. We flipped them around. That would be a false statement also because, hey, I might like a turkey sandwich every once in a while, you know? So then we have the last one, the contrapositive. Contrapositive is going to be kind of a combination of the inverse and the converse. We're going to flip these around and we're going to make them opposites, negate them. So if I don't eat turkey, that's the opposite of this conclusion, then it's not Thanksgiving. And so that one is true. So the contrapositive always has the same truth value as the original statement. Okay. All right. So that brings us to some statements here, some definitions and some statements about some drawings. So here we have a diagram, and we want to decide if these things are true, if we can determine them to be true, if they have to be true. So let's look. Point V and X are collinear. All right? So, well, you know what? Collinear means that there's a line that goes through them. Now, doesn't look like they are. Doesn't look like there's a line, but does a line exist that can pass through those two? I think there is. And so let's see if I can draw a line. Yeah, there would be a line that kind of goes through like that because we have this postulate. Remember, postulates are things that we assume to be true that says through any 2 points there is a line. So we know that any 2 points are collinear. We also know that any 3 points are coplanar. But we don't even really have to look at the graph. If there's only 2 points, we know they're collinear. Now, if there were 3 points, we'd have to look a little more careful. All right. And if there's 3 points, then we have to make sure that there actually is a line drawn through them to be sure. Anyways, line L is parallel to line K. Do we know that? Well, where's L and where's K? Here's L down here and here's K. And so are they parallel? They sure look like it, you know? I think those are parallel, but do we know for sure? We actually don't. So unless we have some other information given to us, we can't know for sure. So we have to say no, and maybe just we say not enough info. We don't have any symbols. We don't have any angles given to us, really. So that's the best we can say. Not enough info. All right. Then is WY on plane P? Plane A, sorry. So WY is a line. Notice the symbol up here. It's a line. And, well, is it on plane A? Well, I know that W is on plane A, and I know that Y is on plane A. And we had a theorem or a postulate that said, yes, if 2 points are on a plane, then the line is. Okay, and so that was our well, point plane postulate, I think it's called, but we can just say if 2 points are on the plane, then the whole line is. Then the line through them is also on that plane. So, all right, last but not least is WYZ, a right angle, WYZ. Well, let's take a look here. And you know, it's kind of laying down, so it kind of looks like it might be. However, if it really was, we'd have to have a right angle symbol right in here. And we don't have one, unfortunately, so it's not told to us, so we can't assume that it is. Okay, so we can say it's not marked, it's not given to us, not enough info would be fine, something like that. Okay. All right. So, got to make sure it's marked, or we got to have some postulate to know for sure that it's actually true. All right. Then we've got these couple laws, logical laws that we're going to use that we learned about. We have the law of detachment, and we've got the law of syllogism. So the law of detachment here, that's the first law. And that law says this. Let me come over here and write it for us. Says, if we know that P implies Q, and we know that P is true, then that means that Q has to be true. Therefore, the Q must be true. Because this statement, if it's true, when the first thing happens, it automatically triggers the second thing. That's the idea of the law of detachment. So, let's see. If the polygon is quadrilateral, then it has 2 diagonals. All right, that's given to us. We don't need to question it or anything like that. That's just true, okay? So if it's a quadrilateral, it's got 2 diagonals, then we're told that, let's make this color coordinated, that we have a quadrilateral. A, B, C, D is quadrilateral. Underline that in red. So that matches the first statement. That's the that's the hypothesis. So we're told that the hypothesis is true, so the conclusion has to be true. The conclusion is that A, B, C, D, that's the name of this polygon, has 2 diagonals. All right? So that rule, that if-then statement is kind of like a rule. So that tells us that whenever you have a polygon or quadrilateral, it has 2 diagonals. All right, great. The law of syllogism, that's our other law. And that says this: if P implies Q and Q implies R, so if we know those 2 things to be true, we can kind of tie them together and say that P implies R. In other words, if P, then R. So 2 if-then statements get combined using the law of syllogism. All right? So here's our law of syllogism. We say this: if 2 angles are vertical angles, then they are congruent. If 2 angels, the angels became angels, or the angles became angels. That's an angle with wings. All right. But if 2 angles are congruent, then they are the same measure. Notice they're tied together by these 2 statements here. All right. And so we can go from the first thing to the second thing. We can say if 2 angles are vertical angles, then, so that's the hypothesis of the first statement. Then we can say that they're the same measure. Okay, that's the last part. And that's how the law of syllogism works. The same measure. So we start with two if-then statements, and we end with an if-then statement in the end. All right? We don't know if we have 2 vertical angles, but the moment you know that you have 2 vertical angles, you can say that they have the same measure. All right, that's the idea. Let's go on to the next page. Review. I'm going to see here, can I just... So our next learning target is I can apply inductive reasoning to find patterns to solve some problems, to help solve problems. So let's do some inductive reasoning here. All right, John made a plan to start doing push-ups every day. Well, that's a good thing. He decided that he would start by doing 2 push-ups on day 1, and then he's going to do 2 more than he did the previous day on each day after that. The number of push-ups he did during each day of the first week would be 2, then 4, then 6, then 8, then 10, then 12, so on and so forth. So the question is, if he continues this pattern, how many total push-ups, so that's a key there, total push-ups, will he have done after 30 days, all right? So every day he does a little more than he does the last day. So this is a big question to add up. We don't want to necessarily just add them all up there, especially if it was bigger, like 300 days. So we need to find a pattern. So we start with an easier question. What if he just did push-ups for 1 day? That's kind of like me. I start something off and then I give up. All right. So what if he only did for 1 day? Well, he would have done 2 push-ups and he's done. Now, if he got a little more persistence here and he did it for 2 days, he did 2 the first day and 4 the next, then that's 6 push-ups. If he went for 3 days, then that would be 2 plus 4 plus 6, which is 12. And then went all the way up to 4 days. At 4 days, he had done 20 push-ups. So he only did 8 on the first day, but we're doing total because that was the question. The question's about the total. All right. After 5 days, if we add 10 more to that, we get 30. After 6 days, he's done 42, so on and so forth. So we want to find a pattern here. And hopefully we kind of recognize these numbers. We've seen them several times. There's a pattern, something special about 2. 2 is like 1 times 2. 6 is like 2 times 3. 12 is 3 times 4, and 4 times 5 for 20. See the pattern there? So we're taking the number 1 times 2. The number of days, 2 times 3. The number of days times that. So it's always the number of days times 1 more. So we have 30 times 31. And 30 times 30 is 900. So this is 900 with another 30. 930. So 930 push-ups. All right, so that's his total, 930 push-ups. All right, so next we're going to talk about proof and some postulates, definitions, properties, and using them to make proof, all right? So when we have proofs, we got to have reasons. And so some of the reasons we need to be familiar with are these properties. So we have 3 important properties. We have the reflexive properties, and we want to give an example of the property using these angles. Well, remember, reflexive is like A is congruent to angle A, all right? So anything is congruent to itself, or B is congruent to B, or C is congruent to C. The symmetric property says if we've got 2 angles that are congruent, A is congruent to B, we should say if, then we can flip it around. Angle B is congruent to angle A. That's a symmetric. Symmetric says we can flip it around there, all right? Then we have the transitive. Transitive we'll use a lot if angle A is congruent to angle B and angle B is congruent to angle C. Then we know the first and the last. Angle A is congruent to angle C because we have a connection here with B. So these guys form a connection, all right? Angle B. And so since they're both congruent to angle B, then A and C have to be congruent. That's transitive. Kind of relates to the law of syllogism there almost, right? All right, so those are the 3 properties we need to be ready to use. Now, here's one. If we know that P is perpendicular to line Q, we want to find the measure of the missing angles. So we're going to justify with a short reason using terms like perpendicular, complementary, supplementary, vertical angles, so on and so forth. All right? So let's go through these. Well, we know that P and Q are perpendicular. So what's angle 3? We don't have to go in order, right? Angle 3 is 90 degrees. Okay? So perpendicular lines make right angles. Okay? So PPD is an abbreviation for perpendicular. We'll use that. So perpendicular lines make 90 degrees angles. All right. So that's why 3 is there. Then, well, P and Q are 90 degrees, so how do we find angle 1? Well, these two angles are complementary, right? So if we have 90 minus 75, then that gives us 15. Sorry, why am I saying 75? Let's go 25. 90 minus 25 is 65. Okay? So this is 65 because angle 1 and the 90-degree angles are complementary. So that could be a reason, something along that line. So that angle 1 is complementary to that angle 25 because P and Q are right angles. All right, angle 2, what about that one? Well, we can do a couple things here. These angles right here are vertical angles. So vertical angles are congruent, and so we can use our vertical angles to get angle 2. Then angle 4 here. Well, angle 4 is vertical angles also. These two are 90 degrees, angle 4 and angle 3. Okay, so those are vertical angles also. Also there. All right. So we got some vertical angles and complementary angles and this going on. All right. One more page. I flip between slides here. Okay, we got some proofs now. Now, I think the proof that was on the paper here said 1 and 3. If yours says 3, this should be not angle 3. It should be angle 2. So make yours into angle 2. You can cross that out. Angle 3 would just kind of not be very useful because it's just 1 and 3 are just a straight line, okay? So, but 1 and 2, that's a little more interesting. All right. So, change to angle 2, and let's get going. We know that angle 2 and 3 are the same. They're measures. So we always start, most of the time, we're going to start with what's given, okay? And then we got to make our way to the end. Now, this may take 3 lines. It may take more. It doesn't have to take 3. Maybe I'll do some wishful thinking and hope that it does. And so the question is, how can we get from one to the other? Well, here's a little clue. There's something about linear pairs. Which ones of these angles are linear pairs? Well, 1 and 3 are, right? So we know that measure of angle 1 plus the measure of angle 3 is 180. And we know that because linear pairs are supplementary. Supplementary means that they add up to 180. Now we know that 1 plus 3 adds up to 180. And we also know that here we have 2 and 3 are the same. So we said that. So our goal is to say that 1 and 2 add to 180. So can we take this and tweak it? I think we can because we know 3 and 2 are the same. So in place of 3, let's put angle 2. So we're going to rewrite this statement as measure of angle 1 plus measure of angle 2 equals 180. And that is because of substitution. All right. So let's take a look at the next proof here. Here we're proving the vertical angle theorem. We've got 2 lines that intersect, and we want to prove that angle 1 is congruent to angle 2. So Let's jump into it. Let's start with our given. You don't always have to start with a given, but it's a good place to start. Then we've got to kind of look at the drawing and ask ourselves, what do we know? So we've got a pair of angles here, like 1 and 3. We know they add to 180, right? And so does 3 and 2. So we can put those in there. We know that those measures, now make sure when you're labeling these, when you're writing these little equations, they should be with a measure, that m. So they add to 180. Don't just say 1 plus 3 add to 180. You got to do the measures. And the measure of angle 3 plus the measure of angle 2 add to 180. Now, how do we know that? Those are a special kind of angle pair. And they have a name because they're connected and they make a straight line. 1 and 3 together make a straight line. Since they make a line, they are a linear pair. And we know that linear pairs are supplementary. And supplementary means that they add to 180. All right? Now, we could break that up into a couple lines to say that first they're a linear pair, and then another line to say that they add to 180. That might be a little more formal, but this is good enough. That'll do for us. Well, if those two things add to 180, if 1 plus 3 equals 180, and 3 plus 2 equals 180, then we know that these two things highlighted have to be equal to each other. So we can make one equation out of that and make it look like this. The measure of 1 plus measure of angle 3, this red one, is equal to the measure of angle 3 plus the measure of angle 4 here, this other one. All right, so those two things are equal. Now, what we just did was we just did substitution. Since one of them was equal to 180, we put it in place of the other one. All right? You could also call this is kind of the transitive property, and we could argue that that's transitive property. They're very closely related, so if you put transitive, that would be okay, but substitution is a more generally accepted one there. Now we got a nice equation, and notice that we have 3 on both sides. We can subtract that, and if we subtract that, we get measure of angle 1 equals measure of angle 2. And that was after subtraction. Now we've basically shown that angle 1 is the same as angle 2. But notice here that we wanted to prove that they're congruent. So it just looks a little different. So we need another line, which you're welcome to do another line. We're not limited to a certain number. So we need to go one more to say angle 1 is congruent to angle 2. And the reason for that is because of the definition of congruence. The definition says if two angles, definition, see if I can spell here. If the two angles are the same measure, then they are congruent. So that's the definition of congruence. All right? That's what congruence means. That's all that this statement says. Great. So there's our proof. This proves the vertical angle theorem. All right? Notice we didn't use the words vertical angle in here. We didn't say that they're vertical angles. We're just saying basically these angles that are vertical will be equal or congruent. So now that we know that vertical angles are congruent, we can use that. So here, these two angles that are opposite of each other, really there should be little degree symbols there. Little typo there. And so we know that these are vertical angles, all right? So these two, top and bottom, are at least. So 2x plus 30 has to be equal to 5x minus 10. And we can solve this pretty simply, right? And so 2x plus 40 equals 5x. Let's subtract. 2x. Uh-oh, looks like we're going to get a fraction here. And if we divide by 3, oh no, can we divide by 3? 40 divided by 3 is 40 thirds. It is what it is. So there you go. There's x is 40 thirds. All right. Who wrote this problem? That's okay. Fractions are fine. Fractions are your friend. 40 thirds. Now, that would be no problem, especially if we could stop there, but we do have to find y. So, well, that's all right. It's good for us to get used to fractions. Let's put 40 thirds in here. We've got to find this other angle here, this 4y plus 45. Well, we know this angle and this angle add to 180, right? They are supplementary angles. So we've got to plug this 40 thirds in here. Now, we don't necessarily want to go decimal, because once you go decimal, then it's just going to get even uglier. So, well, let's practice our fractions. It's really good to get used to fractions, especially as you're headed towards Algebra 2. So you want to be comfortable with your fractions by then. So this is 200 thirds minus 10, but we need a common denominator, so I'm going to write this as 30 thirds. So this is, oh, isn't that pretty? Not really. I'm being sarcastic. 170 thirds. If you want to write a mixed number, you can, but that's just, well, not going to help a lot. So let's go with it here. So we have, let's get rid of that. There's our x, right? No, that's our angle. That's the measure of the angle, all right? So these two angles add up to 180. So we get some equation like that. Maybe I will go ahead and put this in as a mixed number. There we have it as a mixed number. Oh, where are we going? So we have, oh, what is that? 90, 101 and 2/3 plus 4y equals 180. Subtract that. We get 4y equals, if we subtract 101, we get 2/3, 78 and 1/3. And if we divide this by 4, all right, this is a mess because of the fractions. I'm going to multiply it by 1/4. And so that's going to give us y equals, what do we got? 234 thirds times 1/4. Yeah, this is ugly. Hey, I'm going to simplify this. Okay, don't get stressed about these fractions. This is 117. Mr. Durant's in here laughing at me at my stupid fraction answers here. There we go. We'll call it good and we'll call it a day. 117/6. That's exactly what you guessed, right? 117/6. So fractions aside, that's the idea. All right, make sure you're ready to put vertical angles equal to each other and solve for x. And hopefully you won't have to reuse it, because that reusing is a bear. But good fraction practice, huh? All right, well, let's leave it at that. Some basic proofs, vertical angles are congruent, and all the other good stuff there. All right, study hard, and you're going to do great. Keep it up.